In this screencast we show the basic principle of RVL mappings, which is to bind relations, RDF properties, in the data to graphic relations and attributes. Our initial prototype can be used to experiment with RVL. It basically offers two text fields to input RDF data and RVL mappings. As a first step we add some RDF data from DBpedia. The data covers persons that have been influenced directly or indirectly by Albert Einstein, including the type of the persons, scientist, artist, philosopher. First, we need to add the necessary prefix declarations we want to use in our mappings. Let us copy the prefixes from a template. Now we can start with the visualization by creating a first mapping. Unlike in many other approaches, in RVL the graphic types, like bar chart, pie chart, tree map etc., play a subordinated role. Instead we do the graphic encoding on a more fine granular level, that is, we pick a relation in the source data and map it to a graphic relation. For our concrete example, let us map the influenced by relation from DBpedia to the graphic relation, linking directed relation. By submitting the form, both RDF data and mappings are processed by the RVL tooling. The returned JSON is used for driving the D3 rendering of a graphic using a force-directed layout. Each person is represented by a circle and the influence by relation is represented by arrow-shaped lines connecting the nodes. Hovering a connector line shows the relation name. Hovering a node by default highlights all directly related nodes. A different layout can be picked by defining the graphic type, collapsible tree. Since this represents a tree structure, it would be nice to start with Albert Einstein as a root node instead of having him represented by leaf nodes. This can be achieved by adding the invert source property flag to our mapping. Since we switched from a graph to a tree structure, it may have become necessary to duplicate some nodes to various parts of the tree. Hovering one of the nodes will, by default, highlight all nodes representing the same resource. Now let's add a second mapping to distinguish the type of persons that have been influenced by Einstein by color. Again, we create a property mapping, but this time we map to the graphic attribute, color named. Actually, this would be enough to create the color encoding, and the system could pick a set of colors, one for each type of person. Instead, let us add a value mapping to explicitly map scientist to green, artist to red, and philosopher to blue. After submitting, both mappings are simultaneously applied.